Hey everyone, I'm Justin Woodring. In this video, I'll be showing you how to build a single page application and API from scratch. Now by from scratch, I mean we won't be using React or Angular or .NET or Spring Boot. I just listed 4 frameworks, 2 of which are for the front end and 2 of which are for the back end, and we'll be doing both of those things ourselves. The front end will be done standard HTML web page with some JavaScript on it, and our backend we will be doing in C. Now, you may be wondering, why would we do it that way? And the goal of this exercise is not to build the most production-ready software. Well, it's probably going to have a bunch of errors and, or at least vulnerabilities. Um, and so you're probably like, why? That makes no sense. But the reason we're doing this is because this is an exercise in learning exactly what makes a single page application a single page application. I've noticed personally that a lot of people get lost in the complexity of these frameworks. I mean, these frameworks like Spring Boot and React and .NET and Angular are very complex. They're entire topics and, I guess what you could say is specialties in of themselves. And that's not to even get started on the concepts like single page applications and APIs that they abstract over. So, the goal of today is to learn how to build or how a single page application and API work. And I think the easiest way to do that is just to start from scratch, build it ourselves. Hopefully, you'll be able to apply some of the lessons learned in today's video to your more complicated APIs that are implemented in things like .NET. So let's get started. Okay, everyone. So I'm here in VS Code, and I've just got my little folder called single page application, and that's it. Typically, what you see in my experience is that single page applications are structured 2 ways. Either the client folder is stored within the server folder, that is that you either have like the client as a subfolder of the server, or they're 2 separate projects altogether, and they just have at least a little bit of visibility to each other. So in our case, we'll just be doing client and we'll be doing server right here. So there we go. Our client is going to contain our front end, which will be served by the back end, which is our server. And thing is that the client for the most part, should be self-contained. So once we serve that one page, the rest of the application should basically work without a connection to the server. That's the idea behind a single page application. It's a single page that gets served, and then the rest of it just interacts with the APIs that the server provides. So we're going to go make our very complicated server, which is just going to be one C file. So first, we're just going to go ahead and basically include our standard header files. I'm not planning on using anything that would abstract some of the HTTP type or really any other aspect of this server. We'll just be implementing this over raw sockets ourselves. So just go ahead and add our various different headers. These should be standard on literally any Linux system. So, and of course, Windows has its parallels. This is just standard C, so it shouldn't be difficult by any means to find these header files. So first, if you're just doing your standard C file, you're going to make a main function, which is what one would expect. And I can't type, but it's fine. There we go. Okay. And argc. So, this is, if you've never seen C before, this is your standard C file. These are your headers. They include extra definitions for functions and whatnot. So we're just going to do standard right now. First thing to do is just set up a socket. So we're going to set up a socket server. If you've never dealt with sockets before, sockets are basically effectively the backbone of all internet communications. Most of the time, these are abstracted over by more, more sophisticated, I guess, like objects in, your more higher level languages that are capable of communicating specific protocols. But ultimately, everything goes over a socket if it's going over the internet. So, this is your standard C code for opening sockets. And if you've ever wondered why, if you have seen sockets and you've wondered why sockets implementations typically suck in comparison to the rest of the language, like for example, if you've used Python and you're like, hey, why do Python sockets suck so much compared to the rest of Python? I mean, these things I'm typing in to use sockets on Python don't seem very Pythonic. The reason is because it's all based on C. You're using C sockets at the end of the day, and C sockets kind of suck, and they have a lot of these different options, and most of them come from a long time ago. And so that is why you see, these things pop up in all your other languages as well. And, again, most other languages make an attempt to abstract over these concepts, but the reason we're doing it in C to begin with is because other languages do they may have things abstract over it, and we're doing this, raw. We're going to do it as simply as possible. So typically, like in Java or something, not even typically, but in Java and even Python, there's constructs that will serve HTTP for you. There's literally an HTTP server module in Python, and Java has a class object thing that can do the same thing. And we don't want to use any of that. We want to do it ourselves, and we're going to do it in C. So what I'm doing right now is I'm going to, I'm just literally typing in the bind address, or setting up the bind address, you say. This is the basically data that is going to tell the socket or the C program altogether, how to bind to my system's, bind to my system as a host so it can listen for connections. So what this is basically saying is in add or any is equivalent to .0.0.0. If you've ever seen that before, basically means bind on everything all at once, listen for any connection on the public address and the private address and the local loopback address. So it's going to be listening on the local host and everything else that this is connected to, my computer's connected to. So that's what that means. And then our port is going to be htons 80. Now, if you're wondering what htons does, htons is this thing that basically is short for host to network short. And basically, it takes your system and converts all the numbers in your system to a big Indian format. Now, your system may already be in a big Indian format. And if that's the case, then it doesn't actually do anything. But if your system's in a little Indian format, then it will convert it to big Indian. And you may be wondering, first, some of you may be wondering, what is Indianness? And Indianness means indicates the byte order that data is transmitted in and represented in. So your numbers will have a different meaning if they are sent in the reverse byte order, that is little Indian or big Indian. The internet, anything on the internet or networking in general, uses big Indian, and that's the network format. Your host, on the other hand, may use either one depending on the computer you are on. So, in order for network communications to work reliably, you need to make sure that you are sending everything in the network format. And that is why you use htons. So, next, again, in some other languages like Python or something like that, that may be done for you, but here we're going to learn all about it because we're using C. So what this does is, right here, we're literally just we're trying to bind to the address we just specified, and assuming that that is an error, we will say cannot bind, and just simply exit the application with an error code. If the bind is successful, we will try to listen on the same socket. So our socket is just sockfd, and you can find this socket code, or at least something similar to it, analogous to it, on many different tutorial websites. If you want to know what each individual option is doing, you could certainly spend time researching that. This, for example, says that I am willing to accept 5 incoming client connections at once. I can only handle them one at a time, because bear in mind that the code we're writing is not multi-threaded. So in other words, we can only serve one client at a time, and that's not scalable, and that's fine because we're building a demonstration, not production-ready software. So we have created our socket, created the address, bound the socket, and we are now listening for connections. the last thing we're going to do is we're going to, I mean, not really last thing, but the next thing, I suppose, the next major thing we are going to do is actually handle those connections. So what we're doing right here is we're just going to create this little address line. Now this address line is going to basically be the variable or data structure that gets populated when we get a new connection, because we want to, or at least the accept function that is associated with sockets in C needs to be able to populate these variables in order to accept a new connection. And now, naturally, it probably makes sense that you would want to be able to store that data. We don't really need that data because our server is very simple, but some people, especially more complicated software, you know, if you actually were building a complete server host, would probably want to store that data and would likely want to provide it to the rest of the application. So now we're going to do this. Again, this is just some standard socket code for connecting to a client, and you can find this online. In case you're wondering, you know, it's out there. So there we go. So now we're going to handle our new socket. Now, handling your socket. This handle function doesn't actually do anything because we haven't created it yet. But this is where we're going to do the majority of our actual API implementation, because all this stuff up here is literally just listening for connections. So at this point, you could say something like, I don't know, void handle, yeah, new socket. There we go. It's going to handle a socket ID. There we go. And so, you know, we can get to more complicated stuff, but for now, we'll just do something like puts received a connection. And then, obviously, you always want to close your socket after that. You know, and so what we're going to do is we're just going to go test that code. So, if everything's working properly, we should be able to bind to the address and simply access the port at 127.0.0.1, which is my local host on this machine, and it's the local host on basically every Linux machine, so it's not really a surprise. So this is just a page pulled up before I actually am hosting. Compiling C, not complicated. See the terminal down here. I'm just going to do GCC, and then I'm just going to type in my main. Oh, sorry, I need to actually be in my server. So I was in the single page application folder, now I'm in the server folder. GCC main.c. Our application threw some warnings, which is pretty standard for a compiler, especially since, you know, C is, the compiler almost always throws warnings, and that's fine. You could probably fix them if you want to, but I don't really care about fixing them. So we're going to run our server. We didn't see any text output, which means that this thing did not fail to bind, and it did not fail to listen. So it is listening, it's online, it's waiting for a connection. So if I refresh this page up here, you'll see we received connection. Now, you're probably wondering why we received so many connections. That is because the browser, believe it or not, is actually attempting to connect multiple times to the same resource. It's assuming that there was some kind of network fault, and it's going to try to keep connecting because it's like, hey, maybe more than one attempt will be successful. So if you're wondering, that's why we see 10 of those as opposed to one of those. So we're just going to close our connection here. Now, typically, if you decide to run this right afterwards, it may say something like fail to bind. Yeah, exactly. Cannot bind. The reason for that is because it has not freed up the socket resource that we bound to for listening. So it's going to take a little while, and in the meantime, we'll just keep programming. So now, the part that's actually, you know, getting to our code is we're going to create a little response buffer and a buffer. So response buffer is where we're going to store our response to the client. And that would be, in this case, our browser. But really, client can be the form of anything. So typically what you see is, like, you know, in a true API implementation, that the client is not exclusively a browser. It may also be a mobile app on your phone, or even some other API. Okay, my audio dropped out for a second there, but anyway, we're back, and I was finishing up this line. So this line right here, we're actually just putting this response buffer stuff here because, as I said before, the response buffer is for storing the storing the response we're going to send to the client. What I'm doing right here is we're going to be using this memset function quite a few times, and we're just literally using that to clear the memory, fill it with just zeros for or the null operator basically for this entire buffer. And you may be wondering, hey, why would we do that? Well, that's because if you call the same function multiple times and it operates over the same buffer, since the buffers don't clear the same way they do in, higher level languages that have garbage collection and stuff like that, sometimes, even though the buffer is free for our use, it's not going to cause errors if we use it. It may be populated with data that you don't want to deal with. Like, you may not want to consume that data. So we're just clearing it out. That way we don't accidentally send garbage bytes to the client. It's just easier to keep it clean that way. So right now, I'm just going to create this little thing, and it's num bytes. It's just going to be where we store the number of bytes that we actually have read from the client. So we're going to read the client's request. Again, this is just some standard socket code. And size of buffer. So literally read up to the size of the buffer, fill up our entire read buffer, and then we're just gonna parse that request. So next we're just gonna create a couple of fields here. So this proto buff and proto, and then proto first. Now, all of these, so method is going to be, we're literally going to try to parse and store the HTTP method. Then we're going to try to get the file they're accessing, their client's accessing, and then the protocol, or proto buff, which includes the, basically the protocol version, and then also name. So, if you're wondering what I mean by that, let's look at the RFC for HTTP. So this is our method, get. It could also be post, put, or delete, and a couple other ones, but we're not really going to concern ourselves with anything but get, because this is a simple solution. Then this is the file they want to access, and then finally we're going to be looking at this right here. So using our standard C string manipulation tools, we're basically just going to rip apart the request that they send us. So string and copy is just going to we're going to use that to say, hey, copy the number of bytes that I tell you to copy, or technically a number of characters from the buffer that I'm pointing at to the buffer that I'm pointing at. So basically this is your source and your destination's over here. String toke, on the other hand, is a tokenizer for strings. So basically it just returns all the text up to the first delimiter that it sees. String toke is an interesting function, and the reason I say that is because you can call the same function again on the same buffer, and it will start off where the last delimiter stopped, or where the last delimiter was found. So it is very useful for tokenizing a string. But what's curious about it is it actually has a little internal buffer that it can use so that you don't have to provide a path to the same buffer over again. In other words, it has a pointer in memory to the last place the buffer was, or the last delimiter was found in the buffer you originally passed it. So, what that means is that you can call it, and it'll just keep chopping off segments of the string, and that's just the way, arrays and strings work, because all strings are arrays in C, arrays of characters. So it's just basically like, kind of like if I was looking at proto, and I want to chop off at this right here. Then the pointer to the string proto, for example, or character array proto, started off here, and then as you move forward in memory, string toke finds this point right here. And so it saves that location in static memory that's associated with the function itself. And so when you pass it null, it starts off here and runs to the end of string, wherever that is, which happens in this case to be at the end of buff. So it's just going to be like, oh, okay, well, I'm just going to start off here and read whatever. And that's just how that function works. And it just continues to do that. So if you had multiple instances of like, oh, another one of these, then it would just chop off and run to that segment again. Or if you pass a different delimiter, it'll run at that point. But if you don't give it a new buffer, it'll just keep working with the one you gave it last time. So it's just an interesting aspect of string poke. First time I ever dealt with that method, I found it very confusing because I was like, this makes no sense. Until I looked up, like, you know, the documentation / implementation code on some random website online, and then it made a lot more sense. But, you know, if you don't want to do that, that is a simple explanation for you. So what we're doing right here is basically we just write in the method, the file on the protobuf, consistent with get this, and then our actual protobuf, which is this. But the protobuf is split into HTTP and then also it's split into the version as well. So that's what we're using that for. Anyway, so now we're going to say let's split the protobuf itself into its components. So that's what we're doing in this line right here. We're just ripping out the HTTP part, stopping at the slash. We're giving it a new buffer so we can basically do the same thing again. And version, don't need to pass a delimiter. We're actually going to put our \n in here. Now, the reason I say that is because technically every single line in a HTTP request is stopped with a \rn. You can't see it right here, but it's there. And the reason we're doing that is because we don't want that to be in the version itself. So we're just going to basically delimit on that, which means stop right before it gets there. And that will literally give us the version, and that's it. So at this point, we have ripped out all of these different things, and I forgot to rename these. So this should be a file, and the next one should be the protobuf. And then this down here should actually be protobuf because we're operating on the same, null technically. And then over here, we'll be putting in the proto version. So, yeah, this is the way it should work. So again, work through it. Just in case you were a little confused, basically we're going to rip out the method, the file, and the protobuf in these first 3 lines. And then after that, these lines are responsible for ripping the protobuf apart and getting the protocol version, or protocol itself, and then the protocol version. And again, protobuf is literally just to say protocol buffer. Like, it's just a buffer for the text, I guess, is the best way to put it. So next, we are going to actually match on the method. So, again, in any standard API, you need to be able to tell the difference between what method you're using in order to know how to respond. We'll only be implementing the get method today because I don't feel like being here for the next few weeks implementing all the different methods. You know, I think the goal here, again, is not to build something that works completely, but rather to demonstrate how to do it so that if you wanted to build the rest of the methods as an exercise, you could do that. So right here, we're literally just going to now, so we've matched on the fact that we have a GET request. So assuming we have a GET request, we say, okay, cool, someone's trying to get something. Again, the string in comp here, actually not again, I haven't explained this one yet. So the string in comp basically says, this is the equivalent of an equals function. Like, does my string 1 equals string 2? Or if you're using Java, dot equals, because Java's strange. But anyway, basically, what you're doing is we're just going to say if my string get is equivalent to the first XYZ characters of method, which happens to be the size of method. So in other words, if it's equivalent to the first characters of method, or all the characters of method, then it should equal 0, which means the strings are the same. So string and comp can actually do comparisons of whether a string is less than, greater than, or equal to another string. In this case, we only care whether it's actually equal to, so that's why we're using that method there. So we're going to do the same thing down here. Again, that's just our standard equals operation, or our standard equals operation, just for string equality. So now we're just going to match on the side a file that the client is requesting. So the client is going to be saying, hey, I want a certain file. And if you look over here, and again, they would be looking in this case for pub/pub/www/theproject.html. But in this case, they may just be asking for slash. We're just looking to see if the beginning of the request starts with slash API slash. We don't care whether the request has something like, you know, slash API slash something else. So anything that begins with slash API slash, that's what we're looking for. And you'll see we're only matching against the first 5 characters of file. So now we're going to basically just generate 2 different responses here. And actually open that, and I don't mean to open it. Go. So we're just gonna do received a get request to the API for our file using s version s. Okay. If you aren't familiar with what \n does, that is your new line. So it's just basically going to say print a new line whenever a statement is done. And then these %s's, this is how, if you've never done format specifiers in C, that is how you basically insert variables into the output of your like text printing, basically. So some languages may just let you literally type in the thing here, but some maybe some kind of special thing like demarcator, I guess. And you can, some languages also let you just print the variable itself. In this case, this is how you print variables. So like there's different format specifiers for different types of data types. We're doing strings, so %s is what we're going to use. And then assuming that we don't receive a request to the API, we are going to go and print basically the same statement, but without receiving. We're just going to say that we didn't receive a request to the API. We're going to say we received a request, just a GET request in general, for the file, you know, but nothing about the API because we know that it's not under the API route. So again, this is going to relate to the concept of routing in your standard. This is going to relate to the concept of routing in your standard application, or standard API framework, single page application thing. And this is backend routing. Again, front end routing is different. We won't really even be getting to front end routing too much, but we'll touch on it a little bit, at least how a bit how it works. So again, this is your backend router, and so we just know the difference between API and your standard file request. And the reason you need to know this is because most of the time, not all the time, but most of the time, a backend server, when it is serving the front end, either, 1, handles API request itself. In fact, it always handles API request itself. But 2, if it's not an API request, the way it serves the client app is either it serves static files, or it proxies all the requests it doesn't know to another server. In this case, our server will be serving the static files itself. It's simpler and it's standalone, doesn't require 2 separate servers. So right now, we're just going to run this again. Clear our output down here. We're going to compile it, run it. It's been plenty long enough for the port to rebind, so go up here, 8080. We received a request for just slash. So the root of any website is just going to literally ask for slash when it gets sent via a web browser or some other HTTP compatible client. Basically, if you don't ask for anything, you get slash. And if we do slash API, it'll say, hey, we received a GET request to the API for slash API. That makes sense. But assuming we wanted to access a specific endpoint, it can also see that. Again, we're only matching against the first 5 characters of API, so it's fine. It doesn't care about this. You can almost think of that as saying, like, basically match anything under this with a wildcard on the end. But we're accomplishing the same thing by just matching against the first 5 characters. Simple. So I'm going to turn the server back off for now, because we don't need it anymore. Again, if you try to run it multiple times too fast, it's going to try to rebind, or it won't be able to rebind. So just give it a second, get back to coding. You don't need to run it that often anyway. So what we're going to do now is we're going to implement the static file serving. Because first of all, before you have an API or anything like that, it's kind of helpful to be able to have something that can access the API. In this case, we'll be basically setting up the implementation of our actual, actual front end or single page application. So It's going to do the same thing we did earlier with this whole file location, and then we're just going to, so what we're doing right here is we're basically going to try to figure out what the person's accessing, like what's the client want, you know. So just gonna do size path here. So what is the client trying to access? Now, again, we don't actually have a path there, and that's fine because we will get to that. What we do know is the file. And what we're basically doing when we run these two commands is we are concatenating one onto the other. So we're going to concatenate the size of the first onto the second. Now, the buffer size I've chosen here is 150. The file can only be 50 characters long, and the path, therefore, ought to be 100 characters or less. And since we haven't created a path, we will create a path, and that's just fine. So go up to the top up here, and I'm just going to create this little thing called static char path. Boom. Simple. Problem solved. And then, again, doing it that way, I'm not advocating static code by any means. Most of the time people consider that a code smell. Don't do that typically. But this is a simple application, and doing it this way means that it is easy for us to access at any time. Basically makes it global. So we can not only change it, but we can also set it from anywhere when the application starts. So this basically says copy the string ... client to path. So when we access something, for example, like when we access a basically file, and we would say something like slash, the code, the application, the backend is going to look for our file that we're trying to access under the ... client path, which means if it's running in server, it'll go out a directory and then look in client, which is what we want it to do. So we go down, and we're now looking at our static file server code again, and we're going to just print out what we're trying to read. This is always good to, you know, if you aren't familiar with print debugging, it's the oldest thing in the book. Not necessarily the best solution, but it is a consistent solution. You can almost always print in any kind of environment. So debugging code by just printing random stuff so you can figure out what's happening. Not a bad idea. Again, if you wanted to write this to a log, that would probably be the better thing to do, assuming you were building an actual server that was meant to last longer than, 5 minutes. But, we don't need to do that here. We're just building this for demonstration purposes. So I'm creating an actual file buffer now. And the reason we're creating a file buffer is because the response buffer is 2048 bytes. That's 2048 characters text. And for your standard HTTP response, it doesn't need to be any bigger than that. Not really. It shouldn't be. But files are different. Files are typically large, and so like an image may be 55, 60, 70 kilobytes, more even, if you download something off the internet, it may be 500 megabytes or a gigabyte or 2 gigabytes. Doesn't really matter. Point is that our file buffer needs to be a reasonable size to be able to serve most of the assets that we're going to find in our client folder. And your standard HTTP response, standard, bear in mind, for an API may be anywhere from, a few hundred bytes to maybe, a few kilobytes. But certainly not 100 kilobytes by any means, but a file would certainly reasonably be expected to be within that range, and could certainly be much larger. In this case, it won't be much larger. In fact, it won't be any larger because I already know the size of the assets we're using. They aren't very large. The largest thing we'll be serving is an image, but I know the size of that image too, so it's fine. And it's certainly well within the capacity of the buffer. So, and again, also another thing you would typically do is not create a static buffer size, but you would actually allocate that to the heap. But I don't really feel like doing freeing or mallocing on the heap, so we won't be using the heap. We'll be using the stack, and it will be fine. It just may have limitations that you wouldn't want to normally impose on yourself. Especially, again, if you were building production-ready software. But we are building vulnerable software. We are building error-ridden software. And I just copied the same thing twice, I think. Because, no, I didn't. I copied some of the same stuff twice. Because I got distracted. But, so, yeah, we do need to clear the file buffer. And then after that, we're just going to open the file. So, here. File equals Okay. So you're probably wondering, hey, why are we using R+? We're only reading files, you know. Why would we want to write to the file that we're reading? We don't want to write to the file we're reading, but we do want to know if the file is actually a file. So if you were to attempt to do this without doing the R+, you may open a directory. So with just R, it will successfully open a directory, and then you'll have reading errors, and you don't want that. Like it's null like that. And then now we're going to, so we're basically saying, hey, if my file's null, we want to basically try to pass a different location. Now, most people would probably at this point handle an error page. Say, send an error back to the client, say, I don't have this file. In this case, we're building an API single page application. Now, if you are familiar with single page applications, the question I would ask you at this point is, if a single page application has routes on the front end, which means there are routes that are exclusively known to the front end or the page that is sent to the browser, and so the browser, it has these routes written to it whenever the front end is running, but the front end, it can only be accessed via its main root path, like index.html or something like that. So if I go to the server's name / my example front end route, because it's in the history of the browser, and the route isn't there, because the backend server has no idea of it, what's the front end supposed to, like, basically what's the client going to get? The client's going to get a 404, even though the route is known to the front end. So it's written to the browser history, but the backend has no clue it exists because it's really not actually a place. It's just a way of representing data on the front end. So what we want to do is we want to send the application to the client at all times, regardless of what route they ask for, and let it determine whether the page is actually there or not. So what we're doing right now is we're literally just basically taking our file location, and we're taking the path, and then we're writing index.html. So basically point at the standard file we want to return, assuming that the file they're asking for does not exist. This can cause errors. You know, this is not a foolproof solution. It has problems. You can implement workarounds for those problems, but ultimately, you may end up with things like someone getting returned a client app when they're actually looking for an asset that doesn't exist. So, you know, I look for an image and instead I get an HTML file. Maybe the client didn't want an HTML file, but they're going to get one anyway. And you can remedy that situation by looking for, you know, the MIME pipes and stuff that they're looking for. Like if you look at the extension of a PNG file, you'd be like, okay, they're asking for a PNG. Why would I send them an HTML file? Clearly they're not looking for an HTML file. You can also move your assets that you're looking for into a specific assets folder and then be like, hey, if it matches this assets folder, don't send the file to them, the standard client app file. But this is the simple, you know, all-inclusive, generic, kind of like patchwork solution. And again, there are better ways to do it. Ultimately, the best thing you can do is, and by best thing, I mean, actually, we want to use RB for both of these. So, let's do this. So, RB means we want to basically read in binary. And the reason we want to read in binary is because we may or may not be reading our data in, I mean, it could be a file, like it could be an index.html file, it could also be an image. If it's an image, we want to read not characters, we want to read binary data. And the reason for that is because if we try to read as characters, it may corrupt it or just fail to read altogether, miss something. So don't read as data, read as binary. Simple. If it's text, it'll still be compatible as binary. So, you know, you may not be able to read it as a nice pretty little string, but it'll read into some bytes and you can send it and it'll turn out to be a string anyway. You just wouldn't know that until you checked. So basically, again, this my file's like, hey, if my file's null, it means we couldn't find it. But what if we did, I mean, you know, assuming that we did find it, regardless of whether, basically at this point, if index.html exists or the original file we were looking for exists, we're going to try to send our response back to the client. So here we're going to fseek, which is basically going to set the pointer in the file to the beginning of the file. Then we're going to, and that's what the seek sets. So it basically says, hey, seek, set it to the beginning of the file, just like start at the beginning, basically. And that's why we're passing it to 0. So basically, it's 0 plus, or it's an offset, which is 0, plus the from the start of the file. So seek set basically is like, yeah, put it at this point in the file, and we're putting it at 0. And then we're going to read the bytes of the actual file itself. Now, bear in mind, this is different from the num bytes that we had earlier, but it's fine. You can name it better if you want. Again, not the best code, just some code that works. So we're going to use our buffer. You probably would not hardcode this value again. You'd either create a place on the heap for it, or you would just go ahead and yeah, you would just put it in a constant or something like that. But we aren't putting it in a constant. We're hard coding it because, again, not the best solution, just a working solution. And you really, actually, if you look at C code, you see stuff like this all the time. Again, it's not best practice. There are better ways to do it. But it is certainly more than adequate for what we're attempting to do. So at this point, what we're basically going to try to do here is we're going to try to determine the MIME type, or the format type of the data that we're actually basically sending. So the first line we're going to do here is actually just going to read the file name. And the second thing we're going to do right below is try to determine the MIME type. So let's go say, hey, copy into the file name. Again, we're using string in copy, so you saw that earlier. We're going to set it to the string rchar file location of a slash +1, and then copy the size of file name. So what does this do? This line right here basically says, so string rchar is a thing that searches a string for the last instance of a specified character. So we're looking for the last slash in the path that we're searching for a file. So in other words, if someone asks for, basically // client / or not even that, but if someone looks basically for assets / index.html, we're going to ignore the first slash, skip over assets, find the second slash, move the pointer 1 character forward, and select the text that is a hello.html. Make an end because we're just going to read it all the way to the end, or we're going to read as many characters as file name will fit. So perhaps if the file was more than 50 characters name long, like its name was more than 50 characters long, it would just chop off 50 characters. I don't think they were going to have a file named more than 50 characters. It seems kind of asinine that would be the case. So, yeah, I wouldn't really worry about that too much. Now, the second file we're going to be writing here or the second thing we're going to be doing is we're basically going to use a little thing here called char, just a pointer actually, to the little pointer that points to the location of rchar, the file location. So in the last line, we literally just took the pointer that was the result of string rchar. Just took the pointer. Here we're going to store it, and we're going to call it extension. So it's the pointer to the extension. And what we're doing is basically the same thing, except we are just chopping we're looking for the dot instead. So we're basically just chopping at the dot. Now, why we do that, you don't really have to do that. I think it makes it a little bit easier to understand what happens next. So that's why we're doing that. So we're going to basically do a string compare. We're going to look at the extension, and we're going to say, oh, well, if the extension is HTML, then our MIME type is text/HTML, which is the thing the browser looks for, because the browser does not know what you're sending it. So you have to tell it what you're sending it. In some cases, the browser may be smart enough to recognize what you're sending it. In that case, it will probably freak out on you if you send it something and tell it it's something else that it's not. So they're like, hey, I'm sending you HTML, send it a picture. It's going to be like, that's not a picture, or, I mean, that's not HTML. I don't like you anymore. And it'll do stuff you wouldn't expect, like, for example, sending JavaScript as CSS will very much confuse it, and it will fail to execute the JavaScript. And, it kind of makes sense, We told you it was CSS, it's clearly not. So, this is just, these MIME types you can look them up, they're standardized for various different types of files. We're basically just going to copy the same thing over and over because we have a couple different MIME types we need to take care of. And first of which is going to be HTML, obviously, and then the others are going to be, we want to match against PNGs and CSS. So, we see a PNG as a MIME type, we're going to send your MIME type as our extension and it's image/PNG, and if you see CSS, you're going to do text/CSS. And then finally, the last kind, you know, we don't need any more than this, but again, we're matching us the first 5 characters, assuming there's no more than 5 characters, that's fine, you know, and in this case, there shouldn't be more than 5 characters on either one. You could, for example, if you ended a file in .js, you would send application/JavaScript instead, but we aren't handling sending actual JavaScript files. All the JavaScript will be embedded in the index.html file, which we'll get to later. So for now, we're just going to actually get started writing our actual HTTP response. So you're going to do response buffer. So S in printf is basically printf, but it writes to a buffer as opposed to the screen size of my response buffer. And then we're just going to go /s, /r. Okay, so this format string is a little long. It's kind of ugly. It's fine, just bear with it. If you don't know what it does, just keep typing. I will explain it in a second. Basically, it is going to correspond to the various different HTTP headers we will be sending the client. As I said before, HTTP headers are lines separated by /r/n. There's probably different ways you could do this. I chose to do it this way because I like the way that I can put the contents below it. But if you don't like it, you can probably find another way to do it. And this is just my personal preference. Certainly not the best solution, but it works well for a simple solution. So basically, we just wrote that, and now this is the part where we can write most of our HTTP response. So in your standard HTTP response, it's going to look something like HTTP 1.1, 200, that's your status code, and then OK is also the text representation of your status code. We just, you know, broke to a new line, which means that this is going to get inserted right after this, and we're going to put this in there now. So whatever we type next is going to be the next thing. So I'm going to name our server Dinkomatic, because it's kind of dinky, but it is pretty cool too at the same time. So, and then we want to send our content length. So this is where it's important to know the size of the bytes that were actually read from the file. In other words, bytes read. So it's going to pass bytes read in there. You also see that there we go. See that corresponds to the %d right here. That's because %d is an integer. It represents an integer when you want to print it. So as %s represents strings, %d should be where you are printing integers. Content type, this is, like I said, is also important. So we're just going to pass in our file type here, which is also a string, so it should be fine. Then you want to send the content. You don't need to send the content name. You don't really need to, but you can. So I'm going to. And it's going to go that. Again, forgot to put the comma right here. Put it down here. And good. Yeah, and then the last thing you need to send, absolutely must send this, is connection close. So why was sending connection close? Well, that basically tells the browser, hey, stop, you know, trying to assume that the socket, I'm closing the socket on you, so I'm killing the socket, that's fine, that's what we want it to do. I don't need this S here, I just accidentally put an extra 1 when I closed this right here. So now, we're going to tell the person operating the server that we are sending that response. Also, worth pointing out that for any HTTP response, before you start sending the actual content and you're just sending the headers, there is 2 character returns in new lines. So \r/n is a character return new line. It's a standard way of actually doing a new line on Windows, but typically on Linux, you're just going to do a \n. That's a new line by itself, and it resets back to the beginning. But for HTTP, we use this to say, give me a new line, and go back to the beginning. So that's why we're here, you know, when I'm printing to the actual output of the terminal. Linux knows, or Unix systems in general know that \n means you should go to a new line and reset to the beginning. I actually talked a little bit about these format specifiers, or not formats, but these little like codes the other day in one of my other videos. So if you're curious about that, certainly go check that out. But I think that's enough explanation on what that generally does. And as I said before, you definitely want to make sure you have this on the end before you start sending actual content. So we are sending the basically we're telling the client that we're going to send a response buffer. Or not the client, the server that we're sending a response, like the person operating server that we're sending a response. But now we actually are going to do the actual sending. So I'm going to do two separate sends here. And the reason I'm doing that is because one is going to be sent from the response buffer, and the other will be sent from the file buffer. So send one after the other. As far as the socket's concerned, it's like, hey, I just received basically just the same thing, you know, like I received one consistent message because as far as the socket's concerned, it's just a stream of data. It's not like there's some difference between where I'm sending from. So I could split the message up onto 15 different buffers, send them all back, you know, at the same time. And then as far as the client's concerned, it's all the same message on the other side. But it makes it easier for us to know exactly where the file is being sent, how much of the file to send, and all of that. So basically, what we're doing here is we're just saying send socket, send a response buffer. So everything is this basically got written to the response buffer, and then we're going to send it. It's going to send the string length of the response buffer, so the number of characters in the response buffer, and then we are going to send the actual file itself. So we can do print. And then finally, to give a little bit more status to the person operating the server, we'll say we sent the number of response bytes, in other words, the number of bytes that make up the header portion of the response. And then send the file bytes. For small files, you could probably just inline a file into the response buffer. Again, like I said, as far as the, you know, actual client's concerned, it doesn't really make a difference where you're sending from, what buffer it's coming from. But for us, since we're sending a file as well, it makes it easier to separate the two. So if we do this right here, you know, we should be able to see that we are actually, this should run, and if we access a get for any file that is not starting with /API, we should be able to see a response, which would be either if the file is found, that file itself, or index.html. So we're going to go up here. We could implement the API itself right now, but that wouldn't make a lot of sense because you wouldn't really be able to see it working. So what we're going to do is we're going to go work on the actual index.html file now. So we're going to go up here, create a very simple index.html file. Not meant to be complicated at all, you know, we just need to see that it's working. So for the time being, I'm just going to put a little doc type HTML up here, and then put some title in there. Title's one of the easiest things to just get some content up there that you can see. Is like, you know, the Dinkomatic spot. Yeah. There we go. And then, you know, we can put a style sheet in there later, but we don't actually have a style sheet, so it's fine. It's gonna send a body, and we're gonna put an h1 in it and call it hello world. Simple, okay? Not complicated at all. Very simple. Probably the simplest HTML file you could build, and it probably has some errors technically because I'm missing some stuff that's like supposed to make it more readable for people and stuff like that. But it's certainly mostly valid HTML and it'll work just fine. So we're going to start up our server, and we're just going to go ahead and compile it again. Oh, yeah, that's fine. And start it up. So it's, again, we haven't seen any output. That means it's running, it's bound successfully. Nothing about that is a problem. So now we're going to go ahead and access API/hello. So we see that it's still matching against the API, which is good. Means that basically it's not matching against static files because we look for an API route. Now if we try to go to /, we have an error. Typically, you will see that, so actually it started to work successfully. So we see here we got a / client, or / client /. So the file wasn't found, which we expected because we were only accessing the server root, not /index.html. So it's going to try to read client /index.html. This part here likely is an error as a result of this part here is likely an error that's probably a result of one or more lines of code being a little bit invalid. Typically you see this, so we're just going to go back and look at our C real quick and make sure that everything looks good. Probably just some typo or maybe like a missed size of a buffer or something to that effect. So if we go up here and say fseek file equals null, so this is a part where the error would start, presumably either that or this right here. So if I'm in there, I see, and that looks fine. I don't see any errors in that specifically. We were able to get this far before the file crashed. So likely the error is somewhere in the in this code right here. So if we just go looking through it, we will likely find the error shortly enough. We go down here, see string and copy, file name, file location +1. It's fine. Okay, so this is probably the error right here, actually. So that doesn't make any sense as far as the computer's concerned. It's like, I don't know. Okay, in fact, actually, look, file turned blue, which means that it was actually failing to even understand what I was trying to say. Makes sense. So just go ahead and recompile that. If we haven't given enough time, it may or may not fail to bind. Okay, it worked successfully. So we're going to try again. Again, debugging errors at C is very difficult, so just, be patient, go look through it and see, hey, what's something that's obviously wrong. Sometimes it can take a little while. Usually, if it's a segmentation fault, it means you went over a buffer or you just did something that makes no sense. So it's kind of like your standard semicolon missing type of error, like where it's somewhere in here. I don't know where it's at, but you can find it. Okay, so we still got an error, which means that may not be the only error that we have in here. I think that's our issue right there. Our file buffer would likely be not set to 0 properly, which could be causing the issue. I'm just going to change this to 4. And make sure that the buffer is the right size. That's definitely something you want to make sure to do everywhere. So I think that's fine. And we're just going to go ahead and I think that's good. So we're just going to try to compile it and run it. Nope, still not working. Okay, I'm going to kill the video and I'll come back and fix it. Okay, so after a fair amount of digging around, I have located the error. It's right here. This should have been single quotes and I passed double quotes. This string RXR takes a char as a character, and well, strings don't translate to integers, so at least not well. So that caused an error because basically it couldn't find the extension that we were looking for. So when we hit this extension thing, it segfaulted. So anyway, now that that is working properly, we're going to go ahead and recompile, run our server, and here we go. So it has sent the file. Things a little confused. And I think the reason for that is probably because we forgot to close the socket. So it's, waiting for more data, and I think that's, your issue. So we're just going to close the socket right after that, and our problem will likely resolve itself. Here, just go down here. It's fairly certain I closed the socket earlier, but perhaps I forgot. Either that or I closed the socket somewhere else. I don't know. Maybe when I re-implement the code. Anyway, point is, I'm gonna close the socket now. Recompile. Meditate. Okay, it binds. Go. Boom. So you close the socket. Make sure to close the socket, or the data doesn't get sent to the front end or the client, and it has no clue what's happening. Anyway, that's all fine and dandy. We see our hello world, so our page is able to serve some assets correctly. As you can see, we implemented the various different types for PNGs and images and stuff like that. So we can go ahead and include an image in our page. I'm going to include an image called banner. And I think that most of you will probably find it quite familiar, as you have likely seen it at least once before. So I'm just going to go ahead and find my image real quick and move it into the project. Here we go. So that's the image we expect to see online. No surprise, like I said, you've seen it before. And it's a little big because we don't have sizing on it, but it is here. Boom. So again, we were able to serve that from our server. You can see down here actually that is what's happening. Also see that I forgot to put a colon on the content length, which is fine. You can fix that, but that is so it's causing that error right there. So we're just gonna put those there. Not a big issue. There we go. Okay, we have images, stuff like that. So let's move on to the second part of this. The front end is now being served just fine. Front end still is not accessing the API. So let's go modify the front end to make it access the API, and then we'll implement the API functionality. So I'm gonna go right here and just gonna basically blow away all this stuff right here. Don't need that. We're gonna implement this like a true React app though, because said we are going to build a single page application. Single page applications are 99% of the time, not all the time, but 99% of the time, basically all written in JavaScript. We're just going to put all of our JavaScript in a little script tag below the body and inline it. So first thing we're going to do is per your standard JavaScript is to basically wait for the page to load. Not surprising. Probably seen this before if you've done JavaScript, and if not, it's your first time, that's what that is. It's just like, hey, is the page loaded yet? Cool, it is. Everything's loaded in. Let's get started. So you're going to just do some standard accessing the elements of the page. Got our root here. Gonna need that. Now, this is the part where we basically get fancy with our DOM modifications. Or document object model, for those who don't know. It's basically JavaScript's a representation of what the HTML on the page looks like, and we can modify it, and that will modify the HTML on the page. So we're going to append a child here, and the child will be what this thing, it calls it a node. I don't know why, a node is very generic, it doesn't have much meaning. Means also that you can't expect much functionality out of it when it assumes it's just a node. But what we're going to do here is do something a little fancy. And this is basically what you call an instantly evaluating function. And the reason we would do that, so what you could do rather than this is literally just go document.create element and then pass in something like a button, which is what we're going to use. But you could literally have that and ignore this instantly evaluating function, just take these two things away. And you could just do that. But what if you want to add properties of buttons? Do some stuff with the buttons first. That's why we're going to do this instantly evaluating function. It gives us we're going to assign a handle that we can use temporarily with the button. And once we've done that, we're just going to set the ID of the button to button, set the button inner text to click me for the current number of server access. Okay, so that's kind of weird text. Just go with it. It's fine. It's not going to kill you to read it. So now we're going to add an event listener. This is another way of doing an on click. It's fine. Just again, we're doing it the JavaScript way. So here, this is the part where we actually make our request to the server. So, your standard single page application should not have to refresh. It should just be able to do things with the server, interact with the server, and get new data without ever having to refresh. And what we're doing right now is we're basically implementing that reach out to us and talk to the server functionality right here. this is normally done with something like Axios or Fetch, and does a lot of the work for you. But we aren't going to do it that way. We're going to do it ourselves. And most of the types of requests and whatnot that you'll be doing are going to be built on this concept. So I missed a comma right here, and that's why it's freaking out on me, but it's fine. So, like I said, normally you'd be using Fetch or Axios here, but we are doing everything by Scratch, and XML HTTP requests can fetch more than XML. They can also fetch anything that the server is willing to send. So, another aspect of the XML HTTP request is that it just parses, or it receives text. It doesn't know that you're dealing with JSON. Axios or something like that would be able to know that it's dealing with JSON and parse it for you. In this case, we're just getting some text back that's the response. They're like, oh, okay, I guess it's just, text. Even though the server does send the correct MIME type, and we will implement that later. It's not done yet. So we're going to basically assume that the data looks something that gets sent is going to look something like the following. So this, assuming that we're just typing in JSON now, it's going to look like 0. It's going to look like that. This is what our JSON is going to look like when we send it back from the server. So that's what we're intending to parse, that an object that looks like that. And so once we've received that count, we obviously want to document.get element by ID account and set its inner text to equal count. Okay, cool. Bam. That's awesome. Let's go ahead and open the request. Again, all of this is happening once someone clicks the button. So see that it's inside this add event listener, and this is a Lambda function that gets evaluated when someone clicks that button. So this is not going to happen until the button is clicked. You could refresh the page to make this actually happen. You could actually go visit API/counter with your browser, and it would accomplish the same goal of incrementing the count. But at least when that functionality is implemented on the backend. But right now, what we're focused on is attempting to we're working on the front right now, and we'll implement the backend functionality required to make the front end work properly later. Because there's nothing to really see if we finish the backend first. So like, oh, okay, look, there's nothing there. So this is just going to give us our button. If I go visit the page right now, it should, I do need, the server's actually still running for now, so I should just be able to go, yeah, there we go. That's the button. It doesn't do anything. You could click it 8 billion times. Servers are getting the request to API/counter, but it's not going to be able to respond because it doesn't know how to respond. Server's like, I got a request, I don't know what to do here, have fun. And then this thing's like, I'm going to request 15 times because I'm not even getting a response from the server. Server's just like, it's kind of like if you call somebody up and they're just like, they just don't respond, but the line connects and you're like, hello, hello, hello. That's what the browser, or in this case Firefox, is doing to my server that we've written so far, and that's because we aren't giving it a response and we're keeping the socket open. At least until we close it, but it takes a while. And so the Firefox is a little confused, and it's fine. So now we're going to create an element called just make a little BR here. This one doesn't really need anything fancy. Again, I showed you we could do that with the button as well, but we don't really need to add any attributes to the button, so it's fine if we just do it that way. And then we're going to do the same thing here. So, our instantly evaluating function. Very cool concept. I had never used one before I did this. I was kind of like, this must be possible, Lambda functions. How do I instantly evaluate a Lambda function? And, well, that's how you instantly evaluate a Lambda function. Or an anonymous function, I guess you could call it. Equals. So we're setting a span ID. So we're creating a span, and we're setting a span ID to count so that when you set that, this thing here, can access it and update it with the data that we intend to update it with. Span. And again, need to instantly evaluate it, so put that little thing on there that calls it. Done. Here, everything looked good. So that should make the front end work. If there was something for us to see on the front end, which there isn't. So we're going to go back to the server, and we're going to continue implementing that. So we're back in the server now, and I'm going to go ahead and turn off the server. We don't really need it on right now. but we have already implemented a static server, so that's all the static files stuff is under this else right here, running all the way down to the bottom. Let's work on what happens if we receive a request to the API. So we're going to go to our quick. We're going to basically match against the counter route that we defined in the front end. So when we try to access API/counter, we actually want to do something. And so we're just going to match against the file that they're looking for, again, the route or request, I guess. And then size of API counter is literally just going to tell us the size or length of it. It's like, you know, no surprise there. We just literally want to make sure that the string exactly matches that. So at this point, we need a JSON response. And JSON response does not need to be long because we know roughly the size. It's like 10 characters long. It's not long at all. We're going to make the buffer more than large enough to fit JSON response so that you could click the button that increases the count so many times that, I don't know, you probably be a week or two of clicking it constantly before you got it high enough to actually amount to anything. And that's like assuming that you had superhuman clicking speed, so don't really think that's a big deal. With 50 numbers, it's a lot. I don't know, you might die before you, die of old age before you ever manage to click that button enough times to get the count that high. But that is fine. You could also make a script to do it and crash my server. That works too. Again, the server's not secure. So what we're doing here is just, literally all we did so far is create a buffer, cleared the buffer, make sure it's clear. Now we're actually writing the JSON. So we're going to format it properly here, and just going to... So our program, if you use these more fancy libraries, they're capable of serializing some JSON types and stuff like that for you. Counter doesn't exist. That's a problem. But it's a problem we will resolve in a second. For now, we're just going to keep working. So basically, that, obviously counter plus plus means every single time this function gets hit, it's just going to increase that count one time, and that's fine. That's what we want it to do. So every single time you make requests to the page, it should increase the count. That's good. And again, you could implement things like middleware and stuff here in terms of like APIs and single page applications like that. Middleware would be, for example, a database that you retrieve the count from, and you could do that all right here. But I don't really feel like doing that because that's more work, and it's not necessary to demonstrate the concepts that we're trying to show here. And again, the idea is to build the simplest possible solution, and then when you want to add more stuff on, like authentication and like OAuth and all that stuff, fun stuff, cookies, stuff like that, you can do that if you want to, but I don't want to, so I'm not going to. And also the result of which is that I actually have a reasonable chance of finishing this project by the end of the day. So we're going to... So this one here looks a little different, not much. It's a little bit different. Again, you don't understand it, just follow along. Like I said, don't copy the one below. It's a little bit different, and you'll have to modify it, and you might get confused, and if you get the wrong format specifier string, you might break it, so don't do that. Just copy the one I have here. So yeah, right, okay, anyway, so now we're just going to go ahead and go get our content from below. Copy this. Need most of it, not all of it. Oh. Don't mean it. Okay, go back. Okay, here we go. Oh, stop doing that. Okay, copy. There we go. Control C. Perfect. Oh, and I'm failing at keyboard. Okay, there we go. Go up here. Copy. Perfect. Bring that in. Looks good to me. Obviously, you don't want that end on it. Some of these things we don't need. Other things we do need. So content length, for example, should be the string length of the JSON response. And the content type is going to be application/JSON. So that's the MIME type. We know it by heart because we're hard coding it, and that's fine. We obviously know what the server is going to be returning because we wrote this in JSON. Content doesn't have a name. It's fine. And then the last thing is you want to actually make sure to send the JSON response itself. So again, earlier in the previous section, when we were doing the static file, we did this separately. JSON response, or the file response was a separate socket thing, but the JSON response is only 50 characters long, max. The response buffer is 2048 characters. I don't see 2048 characters here, and this is only 50 characters, so that's more than enough to accommodate. Not a big issue at all. So now we're just going to make sure to end that right there, and then we're going to basically tell the server operator something similar. Sending \n response buffer. Perfect. Response bytes send socket response buffer buffer. So again, you saw what sending looks like. That's what we're doing here. Not complicated at all. And finally, we are literally just going to tell the client or the server operator how many bytes we actually sent, which we expect to be the same number as what we intended to send, but you know, it's good to know in case something goes wrong. More or less a debugging type of thing that gives us a control update on status and whatnot. Bytes sent. There we go. Perfect. So take that. It's still throwing an error about the counter, and that's fine. We're gonna go fix that. So you just go up to the top here. And again, not an advocate of statics in general, but they are helpful, especially on proof of concept type work. Done. Worked just fine. So we're gonna go ahead and run our server. File it, run it, go to our browser, and so first we're going to go to the, and then actually type in the route. Okay, so we're getting the response. There we go. So it looks like it's working. If I refresh the page, it says count 1. Perfect. And you see the same down here. So we know that the count is increasing each time we access this page. And that's good. This is demonstrating that kind of like API behavior. Typically your API is going to be more complicated, but this is one that works just fine. So now we're going to go to the actual single page application. And if I click it, you see that the server counts the same. Because as long as the server's running, this is going to keep going up. So I can just go, you know, really click it a lot. You can see it's working pretty well, and it's actually fairly responsive, so it's cool. You can see all the requests for API counter and like the content length and whatnot. And that content length will undoubtedly increase when I get to 100. So you know, and you'll see that whenever it's oh, there we go. Actually, seems like it did not get it go up, and whatever. That's fine. I don't know. That's actually kind of the string length of the JSON response should have changed, but perhaps it didn't. That's fine. Oh, that's it. That's the reason. That's because it stopped rolling. So yeah, it did go up. Anyway, so yeah, I just stopped there, and I thought it was printing the same thing over and over again, and I wasn't paying attention. So anyway, now, you know, we have a relatively working front end and back end, but you know, your typical single page application is not going to look like this. It's going to look a lot better. And so here is where we slap in some styles. It's going to do, and remember, we put in some code to handle CSS, so it should work just fine. Rel equals style sheet and style.css. Okay, I already found some styles. They work for me. I like these styles. They make me happy. So I'm just going to drop them in here. This looks very similar to the default React styles. They are not default React styles. I programmed them myself. I think they're better, and I hope you like them. They are pretty, and they make our app look perfectly qualified to be your standard single-page application. So let's go ahead and, again, server's running. Static files are good, so we should just be able to go refresh the page. Wow, look at that. That's fancy. Spins and everything. Click. Count's still the same. And if I restart the server, again, that static file is going to get reset to 0. Or, I mean, that static file, the static counter is going to get reset to 0, but it's fine the way it is. I think it's a nice, pretty little application. It's adequately mobile friendly and sizey and expandy and stuff like that. It stretches and things. So it's a very nice little application we got there. I think that basically concludes this demonstration. I hope you enjoyed this tutorial, and I hope that if you like to see, or actually if you like seeing content like this, definitely like and subscribe. I had a lot of fun making this, and I hope you enjoyed watching it. Yeah, I'll see you next time.